Okay, welcome everyone to the first part in the matrix series. Alright, so first we'd start off with the definition of a matrix. And a matrix is just a rectangular array of numbers. This here is an example of a matrix. And a matrix is comprised of rows and columns. In this case, we have 2 rows and 3 columns. And this matrix is called a 2 by 3 matrix because we have 2 rows and 3 columns. We call 2 by 3 the order of the matrix or the dimension of the matrix. Now each number in the matrix is called an entry or element. And each entry or element has a specific position. So for example, 1, the position of 1 is the first row and the first column. That is represented by row 1, column 1. 12 will be row 1, column 2. 0 would be represented by row 1, column 3, and so on. So now we know what is a matrix. Now we will talk about a square matrix. A square matrix is just when the number of rows and the number of columns are the same. So for example, in this matrix, we have 2 rows and we have 2 columns. So they are the same, so this is a square matrix. Another example, we have 3 rows and 3 columns. So this is also a square matrix because the rows and columns are the same. Now we will look at identity matrix. Now an identity matrix is a square matrix and it is made up of zeros, where the diagonal of the matrix from top left to bottom right is comprised of ones. So for example, this here is an identity matrix of order 2 by 2, where I is represented as the identity matrix, and we see that the diagonal from left to right is comprised of ones, and the other entries is comprised of zeros. Now let's look at a 3 by 3 identity matrix. Again, it is represented by I, and we have the diagonal from left to right being comprised of ones and all other entries are zeros. Rectangular matrix. A rectangular matrix is a matrix where the number of rows and columns are different. So for example, we have 1 row and 2 columns, so this here is a rectangular matrix. Another example, we have 2 rows and 3 columns. So this is another example of a rectangular matrix. Equal matrices. Now 2 matrices are equal if they have the same entries in each position and they have the same order. So for example, if we look at the matrix A and B, A is a 2 by 2 matrix, B is also a 2 by 2 matrix. And if you look at the entries in each position, they have the same number. Now suppose these 2 matrices A and B are equal, it means that y must be 0, and it also means that x must be 2 for A and B to be equal matrices. Multiplying a matrix by a scalar. Again, suppose we have the matrix A, which is 1, 4, 2, 3, and I want to multiply 4 by A, then for each entry in this matrix, I multiply by 4. So I get 4, 16, 8, and 12. Adding and subtracting matrices. 2 matrices could be added or subtracted if they have the same order. So for example, A and B, they both have the order 2 by 2, so this can be added or subtracted. If we look at this other example, we have C, which is a 1 by 2 matrix, and B is a 2 by 2 matrix. These cannot be added or subtracted because the orders are not the same. So we say that this here is non-conformable. Okay, so let's look at an example. Suppose we have matrix A plus matrix B. We add each corresponding entry of each of these matrices to get a corresponding result. So for example, 1 plus 2 will give me 3. 4 plus 0 will give me 4. 2 plus 2 will give me 4, and 3 plus 1 will give me 4. In the same way, if I take matrix A and I subtract it from matrix B, I get 1 minus 2 is negative 1, 4 minus 0 is 4, 2 minus 2 is 0, and 3 minus 1 is 2.